Alright guys, welcome back to the YouTube channel. So this question says the pressure acting on H2O is increased from 100 kilopascal to 200 megapascal. Calculate the volume decrease in percentage, assuming that bulk modulus of elasticity K is 2 times 10 raised to the power 3 megapascal, right? So first of all, K, which is our bulk modulus, is equal to minus change in P over change in V over initial V. Bulk modulus of elasticity, which is equal to change in pressure over fractional volume change. Now this fractional volume change entail of change in volume over initial volume, but we won't be separating this change over V over initial volume. Don't separate it because that is what we are looking for. We are looking for this. Sorry, let me circle. We are looking for this. So since we are looking for that, we have to make it the subject of the formula by cross multiplying and dividing both sides. So we say change in V, which is our fractional volume change, is equal to negative change in pressure over bulk modulus. And now we can go ahead substituting our values into the equation. So in this question, we are giving our bulk modulus to be 2 times 10 raised to the power 3 megapascal, and we are giving our difference in pressure to be 200 megapascal minus 10 megapascal. Because it is changed, so we have to do P2 minus P1, right? Alright, so going ahead to solve, we get to put this as change in V over V, which is our fractional change in volume, or volume change, is equal to, so our minus, open a big bracket, so we have 200 times 10 raised to the power 6, no, this looks like 16 times 10 raised to the power 6, right, minus, now I'm not going to use 100 kilopascal, I'm going to change it to megapascal, which is going to be 0.1 megapascal, so 0.1 times 10 raised to the power 6, close the bracket. So remember, this minus is outside. So some of you might be thinking, why I changed to megapascal, because I want all of my equation to be in megapascal. So down here, my young modulus is going to be, down here my young modulus is going to be 2 times 10 raised to the power 3 times 10 raised to the power 6, right? So going ahead to solve, I have minus 199.9 megapascal over 2000 megapascal. So megapascal cancels megapascal, so our change, therefore the fractional change of volume is equals to minus 0.09995 and approximately minus 0.1. So multiplying it by 100, we get to have negative 10 values. Therefore, we can say the volume decreases by approximately 10%. So the negative sign there denotes that it is a decrease in volume.